Hey there! I'm Chroma, and welcome to part 17 of Making an Abstract Adventure! Welcome back! This time, we've made a lot of terrain things, namely ice, conveyor belts, and wind. So, one by one, let's show how all this is working. So, starting off with our ice, first showing how our movement looks on the ground normally. Then when we go on to ice, we now slide around a lot more. And yeah, that all functions properly. As well, we can't properly wall jump off of ice because it's slippery. As well, I can't really show this off with a normal wall, but our sticking to walls ability that the cube has also doesn't work on slippery ice walls. But everything else works as it should. Then we have a conveyor belt over here that the only actually moving part is the spinning little things there, and that's just to more easily show what direction the conveyor belt's meant to be moving in. But as you can see, when we're on it, we are being pushed in whatever direction we're meant to be pushed in, and there's a customizable speed that we'll look at in a moment. Then I can also show it with our sphere character. We then have another conveyor belt that's just going up at an angle just to kind of show that off. And then here we have a section with wind, which is just pushing us in a direction. And as we'll see momentarily, the conveyor belts and the wind are kind of coded in a very similar manner. And as well at the moment, a lot of the art here is very temporary, just to be able to, for this, show the direction that's kind of moving, and this just to show, so I can see where the wind starts and stops. But in actuality, it probably wouldn't necessarily be a graphic. It would just make sense with whatever level that we're in. Like, I don't know, if we're on top of like a moving, like a train or something, then there could be wind when you're on top, and that would just be how the level works, and it'd be consistent, so you'd get that there's wind. Or we'd have, like, particle systems that are kind of like blowing particles, so you can tell that there's wind. Basically, yeah, it won't be this random of you just kind of enter a section and there's wind. Anyways, so starting with the ice, because that's what I made first, and should be the easiest to explain of the, whatever, yeah, they're all kind of same-y in difficulty of how they were made and explained, I guess. So, starting with this ice block, it's just a cube, like the ground, except it now has a new tag called slippery. That's then used to know it's slippery. Code-wise, there's actually no code on this. All the code done of whether or not we're in contact with this is done through our players, so that there's less code overall, and it's more optimized, with most of the stuff being done once on the player, as opposed to there being code on every single bit of ice that there might be in the game. So yeah, all this has is just a slippery tag and a box collider as such. In our code, over on our player move script, we now have another float in addition to these other smoothness values that we had before, one called ice smoothness, which if I look at our players, where is it? Over here? Nope. Where is it? Yeah, here. So ice smoothness with Cal, it's set to 1, and with Q, it's set to 2. So then it's also more difference between our players. Our sphere character will slide more than our cube character, just because. Just to have them be more so different from each other. So, so we have this ice smoothness there, and then a public boolean here, or sorry, a private boolean for whether or not we should be sliding. Then down here, all the way at the bottom, in the same area where we tested if we were in contact with a moving platform or not, something that had the tag moving, we are now also testing if we are in contact with a tag of slippery. And if we are, then we're setting that slide boolean to true. If we're not, then we're setting the slide boolean to false. So a lot of the same there than as what we had before. So then, kind of throughout our code here, not necessarily in one specific spot, first starting with slide being false when the game starts, because presumably we're not going to be starting on ice, and if we are, that'll get set to true immediately. So yeah, so here basically anytime that we have a line of code here that was that used to be just move direction equals vector2.lerp moved here to something, as we'll see lower, it's different in different places, based on the stop smoothness or the move smoothness. Anytime that we're changing the move direction based on the stop smoothness or the move smoothness, I then replace that line to if we are sliding. So if the slide boolean is true, we're doing that same calculation, but with the ice smoothness, And if slide is false, then we're doing it how it was being done with the stop smoothness. Yeah, and then this is also in the if statement of whether or not we're grounded, because if we're not grounded, then we're just doing the normal air stop smoothness, because we're not going to be in contact with ice while in air, because it's a ground sliding thing. So if we're in the air, we're just doing the air stop smoothness. Yeah, like slide should not be true if we're in the air for the most part. And it won't really matter if it is. Anyway, so then going down here, any case where there was a case of us moving or changing the move deer thing inside the player ground check dot is grounded, in this case to move smoothness instead of the stop smoothness, that one, then we're replacing it to have this whole if condition of if we're sliding, then using the ice smoothness, otherwise using the move smoothness here, the same thing here, and the same thing here, and the same thing here, and again here. Yeah, and that should be every case of it. There's just a bunch of little replacements in our code here, but it's all kind of the same deal throughout. Yeah, and then in our square wall jump script, then in our on collision enter scripts or functions and on collision exit, during the big if statement of if we're in contact with something that we can wall jump off of, we're then also testing that the thing that we collided with does not have the slippery tag. And then same thing here. And then as well with the square stick function, doing the exact same thing here and here for on collision stay and on collision exit. Now, one thing about this that I've noticed when I was making it is because I'm doing both the moving platform stuff and the slippery stuff based on tags, I wouldn't necessarily be able to have a moving platform that is also slippery. I mean, sort of. I could make like a new tag that says moving and slippery, but there's no easy way of combining this without doing that. I don't know how often, if I'm going to be having moving ice platforms. Maybe. We'll see. And again, that solution I just said, I could do that if we really need to. But this works just fine for now. And then the layer is also the environment layer, because it's something that we can jump off of, as most ground objects are. Yeah, okay, so that's ice, done and dealt with. Then onto these conveyor belts that we have here. Starting off, before we look at... Actually, yeah, this basically has a... Actually, I should probably move this up for better organization. So we have a box collider that is, well, the actual collision of the box itself. It's on the environmental layer 2 because it's something we can jump off of. And then we have this push script, which has a speed and then the direction of the conveyor belts. Yeah, so that way we can like rotate it and then just change what this direction is to be pushed in different ways, and then also have different speeds. And then the actual, these gear things, I don't really know what to call them, just with the spinny things, whatever, spinning wheel, I guess. How they're rotating is, first of all, there's all this, these objects here that make up the actual art of the conveyor belt. And again, it's just putting together a bunch of our temporary white circle and square and all that. That's again all temporary and will be replaced by actual art later on when we're beyond just this demo area here. So with the actual, these wheels that spin, they just have a script on them that I made called spin that we can look at right now. Yeah, that all this does is has a speed and then a Boolean of whether it's rotating to the right or to the left. Then if right, then using transform.rotate, vector3.forward, which is going to get the Z component of the of that vector3 of the rotation, which is basically going to just rotate it by the Z axis, and then multiplying that by speed and by 10 just to have then the number in the inspector be smaller by a factor of 10, and then by time.delta time, because if the game is paused, well, then we don't want it to continue to spin. And then if we're not rotating right, we're rotating left, and then the same thing, just a negative speed. So simple as that. This is also probably temporary. When we have conveyor belts in the actual game, we'd probably have this be through an animation, because it'll probably be, I don't know, maybe more complex of an animation than just something spinning. Yeah, you'll also notice this isn't being rotated through like rigid body stuff. It's just through the transform. It's because it's being done for a, like, not, this isn't something that the player's going to interact with physically. If we had like an actual object spinning, it's like a platform or something, we'd probably want to do that through physics. But that's not the case right now. So yeah, that's that. Then on the actual parent, this push script that we have, we can now look at that. Over here, I don't have it open. Give me 1 second. Or oh, yes, it was over there. Or no, yeah. Okay, so this is a simple script. It just has, it's not really much of a script. It's kind of just holding some values, because I have this other script here, player push, that we'll look at in a second, that's actually dealing with those values. Because again, the actual like pushing is being done on the player, just because it worked better that way. Yeah, so we have a variable called speed and a variable called, or yeah, a speed and a direction, basically, as we just saw. So now over on the player again, over here, so we have this player push script that's on both of them, and this is the one that has more actual stuff to it. So first of all, getting a reference to the rigid body, and then a reference to a push script that we will get the reference to, like whatever conveyor belt that we're in collision with. Yeah, so then getting a reference to that rigid body in start. In fact, I'm actually going to change that to awake because that's just better to do. Then in fixed update, actually no, first of all, going down here, so having two sets of an on collision enter event, an on collision exit event, and then the same thing for on trigger enter and on trigger exit. Yeah, so we're first testing if we've entered the collider of something with the push collider, which the conveyor belt has. Then we're setting push, this script reference equal to the push component reference on that thing that we just collided with. And then otherwise, then when we exit its collision, then we're setting it to null, sort of getting rid of that reference. And then up here in fixed update, we're then saying if we have a reference to a push component script, then we are using rigid body.add force by that push direction multiplied by the push speed times 10. So the number in the inspector could be smaller by a factor of 10, just so it's easier to put in the inspector and it looks cleaner, I guess. Then multiplying it by time.delta time. Actually, that's not completely necessary because we're using rigid body.add force, which wouldn't work. It wouldn't do anyways if the game was paused. But anyway, it's fine as it is. And then doing it by force mode 2d.impulse, so it's more instantaneous and not like as much of a gradual push, sort of. Yeah. So and then yeah, that's that. Then down here, the on trigger sections do the exact same thing as the collision functions, as you can see. So just the one difference is because these get reference to collisions, these get references to colliders. There's a slight difference of us having to go collision.collider.compare tag. Here's just collision.compare tag. Yeah, but other than that, it's basically the same. So that covers the conveyor belts, but actually the wind over here that we have is then being dealt with in the exact same way. So here again, it's a box collider, except this is set to is trigger because we can go through it. Then we have just this sprite renderer that's showing this wind. That again wouldn't be actually used. That's just to show this wind spot in this like test level that we have here. And then the same push script is actually being used. So how both of these are being dealt with is the exact same. And then a direction of whatever way the wind is pushing the player, and then a speed. Yeah, which is why down here, why we have the on trigger part, just so that it's being dealt with in the exact same way. Yeah, and then yeah, it's all being dealt with in, yeah, again, the exact same way. So yeah, that was pretty quick. That basically covers everything. So now we're starting to get into making more like little things. So I might start making like multiple things per episode as opposed to it just being one thing every time. Like this case, making a bunch of things that kind of connect. Next time, I think I might start making buttons, and then with our moving platforms that we made, starting to integrate those together. Yeah, so making different types of buttons, like maybe a time button, one that has to be weighted down. Ooh, I could have a button where that gets weighted down by one character, and then you can go through a door or something with the other character. That's an idea. Yeah, and then we'll continue making stuff from there. So, anyways, that'll be it for this episode. Thank you all so much for watching, and as always, I'll see you around.